Hi, I'm Todd Johnson from the World Bank, and today we're going to be discussing indoor air pollution. We're going to talk about basically what indoor air pollution is as opposed to other forms of air pollution that we've been covering in this course. We're also going to be discussing the difference between indoor air pollution health impacts and those that we've again discussed in urban and outdoor settings. Let me first introduce our two instructors for today that we have here in the studio with us. One is Dr. Kirk Smith. Kirk is Professor of Environmental Health Sciences at the University of California, Berkeley, and he's Associate Director for International Programs at the Center for Occupational and Environmental Health at UC Berkeley Davis in San Francisco. He's the Deputy Director for Environment and Health at the Institute of Global Health at UC San Francisco and at Berkeley. Prior to the University of California, he was at the East-West Center in Hawaii as a senior fellow in the environment program, and he has a PhD in biomedical and environmental health sciences from UC Berkeley, and he's been working extensively on indoor air pollution beginning in the early 80s and has been a pioneer in establishing indoor air pollution as a critical issue for developing countries. He's also a member of the U.S. National Academy of Sciences, so it's very happy to have you with us today, Kirk.
Nice to be here.
Thanks. And the other person that will be talking today is Dr. Enis Barish. He's a medical doctor. He's actually a senior public health specialist here at the World Bank in the East Asian Pacific region. He's also a professor at the Department of Administration at the University of Montreal in Canada. He has a PhD in community health from the University of Montreal, and he also has a medical degree from the University of Hacettepe in Turkey. Enis has worked on a number of issues related to public health, including tobacco control when he was in Canada, and he's also worked on malaria control with the Turkish government. He's worked for a number of international agencies on health, UNICEF, the World Health Organization, the Pan American Health Organization, and he's currently now with the World Bank. Thank you, Enis.
Thank you.
What we're going to do first is basically talk about the issue of indoor air pollution, and we'll have an overview of this. First, we'll also then discuss human health impacts associated with indoor air pollution and look at some of the aggregate numbers associated with what impacts this means in specific countries where this is a serious problem. We'll also then look at the economic and social benefits of reducing indoor air pollution, and including cost-effective measures for addressing indoor air pollution, including various policy measures with overlap. So first, now we'll hear a brief introduction on this overall issue of indoor air pollution and its significance, especially in developing countries, from Dr. Kirk Smith. Kirk?
Thank you. Well, when people think of air pollution and its health effects, they generally think of outdoor urban settings, the pall of smoke that lies over industrial cities in particular. This is indeed how the modern environmental movement started, is with concerns like this, the famous smoky skies of London, for example, and what we see now in the big cities of Asia that burn coal. But in reality, as you can see by the slide, when we're concerned with the health effects of air pollution, we have to consider a range of different places along a chain that's sometimes called the environmental pathway. Furthest to the right, of course, is the reason we're all here, that is the health impacts of air pollution. But we don't have, by the time the health impacts occur, it's too late to do anything normally, so we, in order to prevent those health impacts, one needs to work further back in the chain. If you go to the farthest left on the slide, you'll see that the source of, for example, the fuel that's used in the case of air pollution. That gives you some idea of what the health impacts might be, like dirty fuel versus a clean fuel, for example. But a better measure of the potential for health impacts is are the emissions. That is, how much is actually released when the fuel is burned. Of course, emissions, if they're far away from people, it may not have much impact on the air that's near people, for example, the air in the cities. So we generally do our measurements of outdoor concentrations, as it's shown there, to get some idea of the air that people are actually exposed to. But in reality, one of the best measures of pollution includes an idea of the concentrations, but also of where the people are and what they're doing, what's called here exposure. So this is an even better indication of the impacts. Even better still would be a measure of the dose, that is, how much of the pollution actually gets into the body. But this is difficult to do in most circumstances. So let's consider a minute what it means, the difference between measuring concentrations, which is what you've been hearing about in terms of outdoor pollution, that is, how much pollution might exist on the top of a building in a city where such pollution measures are, and looking at the same pollutant in the context, for example, of exposure, where not only where the pollution is, but where the people are. If you think about it a second, what makes most sense is actually, if you're concerned about health effects, is to measure where the pollution is, not necessarily, it's to measure where the people are, not necessarily where the pollution is. After all, unless we're concerned with some other aspect, for example, damage to forests or climate change, we need to know what actually reaches people. And indeed, if you think about the idea of measuring where the people are, you end up focusing indoors, because most of the people in most of the world spend most of their time indoors. Generally 90% or 80%, maybe 70% or 60% in a rural setting, but 90% in an urban setting. So if you're concerned about where the people are, you need to look indoors. Now, if there are no sources of pollution indoors, then it doesn't matter. But unfortunately, there are a range of important sources of pollution indoors. They may not be important from the standpoint of total aggregate emissions, tons of total pollution, but they are important in terms of what reaches people, exposures. Here's a list of some of these sources of pollution. You can see that fuel burning is a major source, and that's the subject of most of what we're going to talk about today, the burning of fuel for cooking and heating in houses. There's also other types of combustion, of course, the burning of tobacco, environmental tobacco smoke, but also burning of incense sticks or mosquito coils. There are chemical pollutants in cleaning products that come from particularly new furnishings like carpets and furniture. There are also sources, chemicals in paint that evaporate from paint after it's newly applied. And there are radioactive pollutants that come from the ground, radon in particular, that can cause health impacts in certain circumstances. There are also problems in places with biological contaminants, mildews and molds inside houses. Just to illustrate again the importance of looking at things from the standpoint of exposures rather than emissions, here's a list of some of the major pollutant types in the United States. Here, the second line, you can see benzene. The effect is leukemia. Major emissions are from automobiles and industry, but the major part of exposures are from completely different things. If we take carbon monoxide, the bottom line on this table, the major source in the United States is automobiles, but the major exposures occur from not the outdoor pollution in the automobiles, but the people inside the cabin of the automobile who are exposed, and also from stoves. So it reveals, by looking at exposures, it reveals an entirely new landscape, or different landscape, let's say, of important sources, many of which, not all, of course, many of which are indoors. And it tends to change the relative importance of outdoor sources. Now, if we take this idea of measuring where the people are, the next obvious question is, well, where are the people? If we look at this graph, it divides the people in the world up into the 8 most important world microenvironments, as they're called, places where people spend a significant amount of time. That's developing and developed countries. You can see on the right that 77% of the people's time in the world is spent in developing countries. Indoor and outdoor, and urban and rural. These are the other important microenvironments, the way we sort of think about where people are. And as you can see, outdoor, people spend a relatively small amount of time outdoors in either developed or developing countries. The most of the time is spent indoors, and most of the time is spent in developing countries, and most of the time is spent in rural areas. So the largest single microenvironment here, roughly about 1/3, 32% of the world's person hours, is spent in this the larger slice, the green slice on the right, which is rural, indoor, developing country environments. A place where many people don't think that air pollution is a problem. They think of the opposite, or the inverse kind of situation, that is urban, urban, outdoor, developed country settings, which is where most of the air pollution measurements have been. And of course, most of the pollution is. But in terms of exposure, one needs to look where the people are, and the people are indoors. And globally and historically, most people live in rural areas. Well, it wouldn't matter much if there wasn't much pollution in such places. If indoor rural environments are clean, then that's a good place for the people to be, at least from an air pollution standpoint. But unfortunately, this isn't the case. As you see by the next slide, which is labeled a carbon monoxide day in China. This was a day I wore a little device that measured my carbon monoxide levels as I moved throughout the day. And in a computer, it illustrates the level I was exposed to at each time during the day. And you can see on the left, as I started out, I took a car ride and got exposed to air pollution, carbon monoxide in the car, depending on how the car was driving, whether the windows were open, how fast it was going, and so forth. Then a relatively small amount of pollution as we ate lunch, and then we took a visit through some village houses. And you can see exactly how long I stayed in each house, because unfortunately, in this largest microenvironment in the world, where people spend most of their time, there are sources of indoor pollution, mainly in this case the combustion of coal for heating water in China, producing very high levels of pollution. So here you have the recipe for high levels of pollution, high levels of exposure, and consequent high health effects. A lot of people spending a lot of time on a daily basis in a place where fuels are used, as they have been since the discovery or the conquering of fire, one of the oldest of human technologies, the open wood-burning hearth, still be used by billions of people today, producing rather large amounts of pollution. Now, the major sources of this kind of pollution indoors are the burning of solid fuels, principally in a global basis, the burning of biomass fuels. Now, biomass is a term that refers to wood or crop residues, things like corn stalks and rice straw and things like that, left over from agriculture, and animal dung, dried animal dung for fuel. In addition, of course, there are large parts of the world, particularly in China, where people are using coal, unprocessed coal, which also produces a lot of pollution indoors. Here's a list of the type of pollutants that are released in these settings. Particular, like biomass, the most well-studied biomass combustion in the world, of course, is tobacco. Tobacco is a type of biomass. There's some 4,000 compounds discovered in tobacco smoke, more I'm sure to be found. A similar set of compounds is found in the combustion of other biomass, including wood and crop residues. The most important from a health standpoint are a range of small particles, small enough to penetrate into the deep lung, carbon monoxide, nitrogen oxides, a whole range of organic chemicals, including a number that are known to be toxic or carcinogenic, like benzene, butadiene, and toluene, polyaromatic hydrocarbons, more complicated organic compounds with rings that are also known to be carcinogenic. And coal has all of these things, plus, depending on the coal type, may have sulfur or such toxic elements as arsenic and mercury and fluorine, and thereby contaminate the local environment with these things as well. Now, some people think, well, how can this be? Burning biomass is a natural thing. It must be burned very cleanly. But unfortunately, in the small, simple stoves that is commonly used in poor households in the world, the combustion is not very complete, and much of the carbon in the fuel comes off in the form of these various pollutants, health-damaging pollutants. If we look at the distribution of this in the world, about half the households in the world today are using simple solid fuels for their daily cooking and in some cases space heating. Here's a rough distribution of that. Wood and other biomass and coal and kerosene globally. About half the world is using so-called modern fuels, that is kerosene or gas or electricity, and the other half is still using solid fuels. Not all, of course, in the open settings that you saw the picture of, where the smoke comes directly into the household environment, but in many hundreds of millions of homes, particularly obviously in poor rural areas, as in, for example, South Asia and China and Southeast Asia, you find this type of setting. Now, how would you, if you were determining to measure the exposure, as I said, exposure is the important thing, how would you do that in this kind of setting? You can't just put a few devices around, as you can in a city, and get some idea of the outdoor concentrations. You have to have some way of finding out what's going on in hundreds and millions of households if you're trying to understand these, the health effects, the exposures and the health effects. Well, there's a so-called pyramid of exposure assessment as a way of doing this. Ideally, if the top of the pyramid with the least uncertainty, the most precision would be some sort of biomarker, a measure of something in the saliva, for example, or taking of a bit of blood that would tell you exactly what has happened. These are expensive and difficult and sometimes a bit risky to do, so they aren't done on a routine basis. And we don't know how to do it for some important pollutants. You can move down the pyramid to things that are more uncertain but less costly, for example, continuous personal monitoring, or where you actually have people wearing devices, as you saw that I was doing in the previous slide. This is also kind of expensive and not possible to do on large scale on a routine basis. If you go all the way down to the bottom of the pyramid, it increases the uncertainty but much lowers the cost. You can rely on secondary information, such things as what is the percent of households in the country that use a certain type of fuel, what percent uses wood or what percent uses coal. This gives you some idea of the potential for ill health. Even better, and one of the major ways of getting at this is to use household questionnaires, for example, as part of a national survey or the national census. As you can see by this slide of India, the Indian census does include questions about fuel use throughout the country. So we have a pretty good idea in the case of India how many households in each part of the country are using which kind of fuel. Here's an illustration of the biomass fuel use in India. You can see that a very large fraction of the country is using most of their household energy in the form of biomass. And thank you. And indeed, India-wide, something like 80% of households use biomass fuels. So this gives you some idea of the type of pollution, although, of course, not as precise as actually measuring. There are two principal ways of measuring exposure, the so-called direct and indirect. As shown here, the direct way is you actually wear a device that takes a sample of the air from the breathing zone. Indirect way is to identify where people spend most of the time, what fraction of the time they spend sleeping, what fraction in the living room, what fraction outdoors, and so on, and to measure the pollution in each of those areas. So that's the microenvironmental approach. You divide up people's time into the major microenvironments, and then you measure in each of those microenvironments. If we go to the next slide, you can see a little bit of how this might work in the case of direct measurements. This is a woman in Western India. You can see the device that she's wearing on her hip is an air pollution monitor, and there's a tube that comes around right underneath her chin, and that's taking a sample of air from her breathing zone, and thereby gets a pretty good idea of what she's actually exposed to. This, in fact, as far as we know, this particular photo is a picture of the first woman in human history to have her air pollution exposure measured using one of the oldest technologies in human history. So thank you very much.
Thanks, Kurt. I know you stressed this many times in your presentation, but I think it's worth bringing up again, and it's this issue of exposure. And it just struck me that it doesn't have to be a major source of total emissions, which again is right. When we look at countries and what they measure, we often look at emissions, but it's very pointed that really is what people are exposed to. I don't know if you want to, once again.
Well, yes. I mean, this is the point here. People tend to think of air pollution in the context of total emissions, and for some types of impacts, climate change or acid rain or even visibility, these are the important issues. But for health, you're really concerned about what reaches people. I mean, think about the worst case of emissions versus health is cigarettes. You're actually putting the combustion inside your mouth. 100% of it goes down your throat. If you're releasing the pollution inside a building with other people around, say a household, then maybe only 1% of it goes down people's throat. But if you release the pollution from a smokestack far outside of town, like in a coal-fired power plant, less than 1 part in a million goes down people's throats. So it doesn't take very much release indoors to be more important from a health standpoint than a lot produced outdoors.
Yeah. One thing I've always found interesting, I've heard this before, is that when you did this monitor, when you went through in China in a rural setting and went into these households, and it basically measured these. This was a CO monitor, is that right? I'm assuming that was correlated with other pollutants. I mean, I assume CO is not the main. I assume CO is not a good thing to be exposed to, but is it also correlated with other pollutants inside a household?
Well, one of the problems with this type of work is that the best single measure of pollution is probably small particles, but they're more difficult to measure. In fact, you look on a pack of cigarettes, again, which is a burning biomass, it lists the tar level. Well, that tar level is the cigarette people's way of talking about small particles. It is basically what's trapped on a filter. So if you wish, the tar level in the households is what we need to measure, but it's difficult to measure, and the devices to do so are hard to use or expensive. Now, correlation, yes, there does seem to be a correlation between such things as carbon monoxide and the particle levels, but unfortunately, that's specific to each fuel. So the correlation for coal will be different for the correlation for wood, so you can't use it across fuels.
Right. Did you have a question, Ennis?
Yeah, I have a question to Professor Smith. It will be a bit venturing out of my own field, but one of the things that we often talk in development is the famous the energy ladder. That some people claim that it's just a matter of time that eventually, as the countries get more developed, they will move away from solid fuels towards more efficient fuels, and most of the problem will go away. Yet I've seen some data showing that actually the use of solid fuels have been stabilized in some countries, and in some countries where the poverty is rising, actually some people may revert back to solid fuels. What do you think about that? What do you think? How long this problem will be with us in this century? Actually, I mean,
or is it going to solve itself? I guess is part of it.
Well. In a broad sense, this is true. This is one of the many problems of being poor. I mean, it's unhealthy to be poor, as we all know, and this is one of the reasons for it, like having poor access to medical care or having poor food supplies and poor sanitation and so on. So in a sense, it will solve itself when people become better off. But I would say that if you had to pick a single most important definition of public health is the art of making people healthy before they're wealthy. It's no trick to make people healthy when they're wealthy. It's the art of making them healthy beforehand. So we don't wait until people become wealthy to help them get better sanitation and cleaner water, because we know that health itself is a major benefit. In addition, of course, if you want the economy to grow faster, you need healthy people. And if you want education to work more effectively, you need healthy kids. So the causation works both ways. That is, if you want the economy to grow, and we do because of the many advantages it brings, we need to have healthy people. In addition, of course, health itself is a separate value in society in addition to economic well-being. So I would say the question is on indoor air pollution is that can we intervene with cost-effective measures that will make people healthy before they become wealthy, or do we have to wait I'm afraid, given the trends, as you mentioned, that we would have to wait 50 years or more, even if we don't have major dislocations in the world, and we probably will, before those 2 billion people or more who don't have access to clean fuels will have them on their own.
Good. Thanks, Kirk. Obviously, a lot of these issues will come up during the course, but I think it's a good introduction in this issue of indoor air pollution. One of the issues that, again, Kirk raised is this issue that we find that one of the least studied areas is in rural areas, is in developing countries, and is in indoor air. And what we don't know oftentimes is what some of these pollution levels in indoor areas are. What we're going to see now is a video from India, which basically looks at some measurements and some studies that have been done on exposure in India. And we have with us on this tape is Dr. Kalpana Balakrishnan, who is head of the Environmental Health Program at the Sri Ramachandra Medical College and Research Institute in India. She has a PhD from Johns Hopkins and has worked extensively on indoor air pollution with a number of groups, including with Kirk Smith and others. So right now we're going to see this tape on India. Thank you.
Some of the earliest studies concerning biomass combustion and indoor air pollution were conducted in villages of northern India. Professor Kirk Smith and his colleagues at University of California, Berkeley, in collaboration with researchers at the National Institute of Occupational Health in Gujarat, conducted some of these earliest studies, both in villages of northern India and in western India in the state of Gujarat. It is estimated, based on some of these earlier studies, that the population weighted mean, the mean 24-hour exposure to respirable particulate matter is in the range of 700 micrograms per meter cube. Although biomass smoke emits a variety of pollutants, in all these studies, respirable particulate matter is taken as an indicator of overall indoor air pollution levels. Many of these earlier studies relied on short-term measurements, measurements that are taken, for example, only during the cooking window, or measurements that may be taken during non-cooking periods. And based on these multiple short-term measurements, 24-hour average concentrations and 24-hour average exposures would be generated. More recently, large-scale quantitative assessments have been completed that enabled us to make a much more rigorous quantitative assessment. While it is fairly well recognized that cooks are perhaps the most exposed subgroup compared to all the other subgroups of household members, one can imagine that if the concentrations in the kitchen and the adjacent living areas are also high, other household members too would run the risk of high exposures. Therefore, in addition to assessing cook's exposure through personal samplers that the cook would bear, for example, in order to assess his or her exposure during the cooking window, measurements were also made in other household microenvironments. Measurements were made in the kitchen, in the living area, and immediately outside the house. Subgroups of household members who necessarily may not be the chief cooks, but yet have high potentials for exposures, such as young female children, were also covered. Household configurations, especially location of kitchen and the configuration of the kitchen itself, could play an important role in influencing exposures. If, for example, you had a household in which the kitchen was not partitioned from the rest of the living area concentrations tend to be as high as the kitchen area concentrations, exposing all those members who are likely to be indoors to levels as high as that experienced by the cook. Exposures certainly would decrease as we moved from this configuration to a configuration in which there is a definite partition between the kitchen and the adjacent living areas. There are also other kinds of kitchen configurations possible in which you might have a kitchen that is outside but yet enclosed and connected to the rest of the household, or at the extreme end of the spectrum, not have a kitchen at all, just cook outdoors. Recognition of the differences in household configurations is very important in order to be able to capture realistically what the exposures are for different household groups. Basically, it's not just the cooks that may be at risk of high exposures, but also several other subgroups who are likely to be influenced by what the household configuration is for where they are when the cooking goes on. It also requires multiple types of measurements that would involve attaching a personal sampler to a cook during cooking periods. But wearing these samplers is almost impossible for the entire duration of the day. This shortcoming has to be overcome with the aid of area samples that are placed in different household microenvironments, the kitchen locations, the living locations, and the outdoor locations. And when you have information on the 24-hour average concentration in these household microenvironments, one could begin to collect detailed information from the household members as to where they are and for how long they are in these different microenvironments. These time activity recalls, together with household level concentration information, allows us to reconstruct exposures for the different types of household subgroups. Some of the kinds of information